So right now, we're only going to look at a couple of these. We're going to look at this one, y equals 4x plus 4. We're going to look at the one right below it, y equals 8x minus 3. We're going to look at the bottom one on the right, y equals 6x minus 4. And we are going to look at y plus 6x equals 11. And we're going to look at the one above it. So we're going to look at like half of them. Oops, that's not right. Y equals, sorry, y plus 4x plus 6 equals 8. So the reason I'm looking at those is those should be incredibly easy. Incredibly easy. So, yes, Sarah, let's look at this one right here. What's the slope of that one? Y equals mx plus b. Which number represents the slope? Not 4. Remember, m is slope, right? So 6. So in the slope column, you're going to put 6. So now, Kaylin, why do you think I picked this one? Because this one doesn't look like y equals mx plus b. Can I make that one easily look like y equals mx plus b? By doing what? Right? Bring the 6x to the other side. So if I subtract 6x to the other side, I get that. So I'm going to go back in this little box, right? And I'm going to write that's the same as y equals negative 6x plus 11. So then, Winter, I know you were out, but which one's the slope, the negative 6 or the 11? The negative 6. The negative 6. So, Marcus, what's the 11? What's the negative 4? Y-intercept. So y-intercept 11, negative. So I want you guys to do these two because they're already set up for you. And then I want you to do this one and set it up so it's y equals whatever. Okay, so those top three. The top two on the left are already set up for you. The one on the right, you just have to bring everything to one side. So take a minute and do that, please. Right? Take a minute, do that, please. Yes. Well, we're not really solving it on any of them. The slope is 8, the slope is 4. The y-intercept is 4, the y-intercept is negative. Yeah, don't worry about it. We haven't even talked about it yet, right? We're setting ourselves up for tomorrow on this one. So this one, so on this one, right, all I want you to do is make it look like this. So how do I take these two things and bring it to the other side? Yeah, so, and then same thing, subtract 4. Always, right? So y equals, what is it going to do? If I take the 4 and bring it to the other side, what is it? Positive 4 and negative 6. Yeah. No, I have to subtract it, right? Oh, yeah. Yeah, so if I take this and you've already subtracted the 6, it's that, right? And then subtract 4, it's where's that one coming from? Is that this one? The same as this one? Okay. All right, so Emma, how do I rewrite this one? How is this one going to be rewritten? Good. So y equals negative 4x minus 6. Okay? So again, these are slopes and y-intercepts. All right, so Jake, how about the slope of this one?
-4.
-4, y-intercept?
Oh, it's like slope, I meant.
Yeah, slope is -4. How about y-intercept?
You put it like that in the y-intercept.
Oh, thank you. I apologize. My eraser's not using, right? And how about y-intercept?
0.
Not 0, right? Y-intercept is right here, your B.
6.
So 6. You got to use this one and not that one. So -6, -6. Okay. Adriana, how about this one? What's our slope? 4. Y-intercept? 4. Same thing. Right? And Hunter, how about this one? Slope?
8.
Y-intercept? Yeah. Okay. So the reason I kind of did that now is because we were just coming off of y equals mx plus b, right? So all the other ones we're going to leave for tomorrow. We're going to do something else with those and those tomorrow. So again, I just kind of wanted to set ourselves up because we just came off of y equals mx plus b. All right? All right, put your packet to the side. And if you're a note taker, right, you want to take some notes out. We're going to talk about 4 special cases. Right, special cases. And here are our 4 special cases. Vertical lines, horizontal lines, perpendicular, and parallel. So I've got 4 different graphs. Which one's vertical, which one's horizontal, which one's parallel, which one's perpendicular? Yeah, that's an actual question. Why can't that be an actual question? It is my intro. Don't you love my pictures? Aren't they beautiful? Right? Caleb, yes, sir. You can use that one, yeah. Nobody's there. Okay? All right. Cliff, which one's vertical? Top, bottom, left, or right? Which one's a vertical line? Left, bottom? Right? So this one is our vertical line. Right? This one's our vertical line. So if you need an example of a vertical line, give it a draw. Kaylin, what axis does that go through? X-axis or Y-axis? X-axis. Vertical lines are extremely easy. The equation is always x equals some number. Always, always, always. And the way I want you to remember that is it passes through the x-axis, right? Passes through the x-axis. Harper, so you got the other easy one. Which one's horizontal? Top right. This one is our horizontal line. And I got another always for an equation. Meaning what axis does it go through? Y. So it is always y equals some number. Always, always, always. So horizontal and vertical lines should have no work whatsoever when you do equations. Because all you got to see is a point that it passes through, right? And then you just write that equation. Did you not? All right, so just wait a couple minutes. All right, so then parallel, top left, right? Isaiah, what does it look like that is true about parallel lines? Do they have the same y-intercept? Are they crossing the y-axis at the same spot? No. Do they cross the x-axis at the same spot? No. So again, those 3 things that I just wrote, x-intercept, y-intercept, do they have the same slope? They do, right? So that's what you want to remember, right? So I'll call the top one line 1, and I'll call the bottom one line 2. So they have the same slope. So the way that you write that is I like to use little subscripts. M1 equals M2. The slope of line 1 equals the slope of line 2. All right, so what about our last picture? I'm hoping you think it's our last one, perpendicular. But what does perpendicular mean? What does perpendicular mean? It doesn't mean just intersect. Manny, were you going to say intersect? They have a 90-degree angle. So they intersect at 90 degrees. Marcus, were you going to say the same thing?
Yeah.
Right? Intersect at 90 degrees. Do you know what's true about their slope? Not zero. Not zero. This is usually the tricky one. So I'm going to do the same thing. I'm going to go line 1, and I'm going to say this one is line 2. So this one I said same slope. This one is opposite, reciprocal. I'm not going to fit it there. Opposite, reciprocal. All right, so Hunter, what does that mean? What does opposite mean? Guys, we got like 3 phones up there. There's like 17 of you here. We should have more phones up there every day. Hunter, what does opposite mean? Opposite. In numbers, what does it mean? You totally know. You totally know. Opposite. 5 versus negative 5. 7 versus negative 7. A half versus negative a half. What's the difference? Hunter, what's the difference? Positive and negative. Opposites. Right? So opposite means that one is positive, one is positive, one is negative. Right? One is positive, one is negative. Anybody remember what reciprocal means? Reciprocal. Reciprocal. Flip, right? Reciprocal means that you're going to flip it. So opposite reciprocal means the signs are different and we're going to flip it. So I'm going to try to write it in a way to help you remember, right? So the slope of any line, I'm just going to say A over B. So Quinley, what do you mean what do you think I mean when I do flip? A over B, if I flip it, what is it going to be? B over A. So I flip it. And then one's going to be positive. The other one has to be negative. So I don't know if you guys heard what Marcus said up here. He said something about 0. I don't, maybe this is what you were trying to remember, Marcus. When you multiply them, you don't get 0. You get negative 1. Okay? That's what opposite reciprocal means. Okay, so parallel and perpendicular can be the harder of those two, right? Harder of those two. So we're going to do some vertical and horizontal first. Those are going to be nice and quick, okay? Because again, there's not much work. I am going to try to give you, I think, 4 situations for vertical and horizontal. And then we'll probably get to maybe one example of each of parallel and perpendicular. Parallel and perpendicular we'll do today and tomorrow. Okay, so let's do vertical. And again, sometimes I always don't use all the slides I put up here. I end up deciding to do them differently. So I already showed you this slide, right? So these are the 2 that we're working on first, vertical and horizontal, right? So I already showed you that last class, okay? So let's work on horizontal first. So horizontal, always y equals some number. So that b is some number. So I'm going to try to give you every situation that I can for horizontal lines. So again, I think there's 4 of them. So find the equation of horizontal line right, so first situation. Passes through 7-11 and 21-11. 7-11 and 21-11. So plot them, right? If you were to plot them, and I'm going to totally do just a rough sketch. 7-11 is a point right about there. Then total rough sketch. 21-11, point right there. So mark it, same X or same Y? Same X or same Y? Same Y. So they have the same Y value. Right? Same Y value. Caleb, what axes does it go through? What axes does it pass through? This one's my X and this one's my Y. Are you okay with the Y? Right? So it passes through the Y-axis. Right? That is my Y-intercept. So there's no work whatsoever. The equation is Y equals whatever the Y is. Y equals 11. No work whatsoever. All right, so second one. I can say passes through, and I'm just making up random points. Passes through 112, comma, 5, and is a horizontal line. Again, I'm trying to give you each situation, and is a horizontal line. So what I want you to do on that one, I want you to visualize it, right? I want you to think, I'm drawing a horizontal line. So what axes does it pass through? Horizontal line. What axes is it going to pass through? X or Y? Horizontal line. Doesn't a horizontal line pass through the Y-axis? So again, no work. All you have to do is go Y equals whatever the Y is. Y equals 5. So if I'm telling you it's a horizontal line, this one's the hardest one. This one's the hardest one. Passes through 17,25 and has a slope of 0. Passes through 17,25 and has a slope of 0. What type of equation, what type of line has a slope of 0? Horizontal, right? And the way to remember that, right? A horizontal line has a 0 slope. So that one's the hardest one, but again, no work whatsoever. Y equals 25. All right, Y equals 25. Really, is that okay? What's the matter? What were you questioning? Totally say it. Someone else might have the same question.
No,
Okay. All right, and then number 4. Number 4. I might have to skip a slide. Nope, I don't. If I give you a graph. Right? So number 4, graph given. So what's the equation? Right? Y equals -1. Right? No work whatsoever. So I'm going to tell you, a ton of people, right? You guys are going to ask questions when we have this on a quiz or a homework or whatever. And you're going to be like, I don't get it. But there's no work. There's no work to show for it. Okay? No work to show for it. All right? Let's do vertical. All right? Let's do vertical. All right, so vertical. So I'm going to do the exact same thing. I'm going to give you 4 scenarios. I'm going to try to do it in that same order. So a vertical line is always x equals some number. So give the equation of the line. Give the equation of the vertical line. Equation of vertical line. All right, same thing. Passes through. Passes through. 12, 14, and 12, negative 100. So think about plotting those points. So I'm going to ask you the same question. What axes does it pass through? So plot them, right? Plot those 2 points. What axes does it pass through? Again, I'm not going to make a graph of like negative 100, but I can sketch it. 12, 14, 12, negative 100. Papa, what axes does it go through? Goes through the x-axis. So that's how you're going to remember. X equals whatever the x is. X equals 5. I want to do them in the same order that I did the last one. So my number 2 was passes through a point. So through 17, 100, and is a vertical line. Right? And is a vertical line. So I can make that picture be the same picture, right? 17, 100 is right here. I draw through a vertical line, right? Draw through a vertical line. Cat, what axes does it pass through? X or Y? It passes through the X. So this point right there would be 17, 0. So same deal, no work. X equals 17. All right, Manny, what type of slope does a vertical line have? What type of slope? Say it again. It can't have a slope, and he had said no slope, right? So again, an N, right, is no slope, or some people might put undefined. So same deal, right? So through negative 111, 22, that has an undefined slope. Undefined slope. So again, I'm trying to give you every single way. So, Adriana, what do you think?
X equals negative.
Yeah. X equals negative 1. And then last one, graph. Last one, graph. So, what's the equation? X equals 3, that's it. You just look at it, it passes through the x-axis, x equals 3. So those should be nice and easy. No work for those whatsoever. Caleb, that's good? All right, let's do parallel and perpendicular on these, and then let's do parallel and perpendicular on some ones that aren't horizontal and vertical. All right, so give me an equation of a line that's parallel to x equals 5, and then give me an equation of a line that's perpendicular to x equals 5. So I'm going to draw x equals 5. So I go to the line, I go to the x-axis, I hit 5, And then I'm gonna draw a line that's vertical, because that's what my x is. So what's gonna be an equation for it being parallel? What's gonna be an equation for perpendicular? Is there only one answer? Are there only two answers? Can everybody give me a different answer? So 0 answers, 1 answer, 2 answers, many answers? What do you guys think? You see, how about parallel? How many other vertical lines can I draw that's going to have the same slope as that one? An infinite number, right? Infinite number. So parallel is going to use the same letter. So x equals whatever number you want. 51. Right? Any number. Any number you want. So then, Quinley, what do you think about perpendicular? If that one's vertical, which way does perpendicular have to go? Opposite, so horizontal, right? So I like that she said opposite, because it's got to be the opposite letter. Y equals, doesn't matter, negative 70, right? Whatever number I want. Any. All right, so vertical, horizontal, those are good? All right? All right, now we're going to do parallel and perpendicular, but we're going to do it with increasing and decreasing lines. Right? Increasing and decreasing lines. Okay, so write an equation parallel to, y equals 3x minus 1 that passes through the point 9, 2. Parallel to 3x minus 1 that passes through 9, 2. So let's go graph this one first, right? We'll call this one line 1. Isaiah, how do I graph that? Y equals 3x minus 1. What's the 3? What's the minus 1? Tell us in terms of graphing it nicely. Good. Negative 1 is your b, which is your y-intercept. So negative 1. 3 is the slope. So what am I going to do for my slope? Like, how do I do it on here? So it's going to go like this, but does it go like this, or this, or this, or this? How do I know how much it goes? Good. So rise over run, right? It goes up by 3 and over 1. So it's a pretty steep slope, right? Pretty steep slope. All right, so now I want to do line 2. Line 2 has to pass through 9, 2. Right? 9, 2. So we said parallel, same slope. So Jake, what slope am I going to use with 9, 2? What is the slope of line 1? 3. So my slope is going to be 3. So I can go draw it first if I want. Rise 3, run 1. Manny, do those look like they're parallel? Do they? They do. So how do I get the equation? What equation did we use yesterday with a point and with a slope? What did we use? Negative 25y? Oh, you're plugging it into mx plus b? Okay. So let's see where he can get that from though, right? So we're going to use y minus y1 times m times x minus x1. So he did that pretty quickly in his head. Let's see if he's right. So n being 3, right? I plug that in, n being 3. Caleb, where does the point go? 9, 2. Where does the point go? What variable are your points? X and Y. So which one are we going to plug them into? The Y or the Y11? The Y11. You always plug it into the second one. So I'm going to go Y minus 2 equals 3 times X minus 9. I think he was good with this 25, but I think it was supposed to be negative, I think.
Yeah, said negative.
Right?
No, I said negative.
Right? So Emma, what do we do over here with this 3? Distribute it. So we get y minus 2 equals 3x minus 27. So then add 2, and you get 3x minus 25. So here's a question. Does this black line look like it could hit the y-axis at negative 25? Does it look like it could? I think so. No, did you do y equals mx plus b? You probably did it in your head and thought about it, you just didn't write it down. Either method is fine. All right, so let's have you guys try one. All right, you guys try one. So let's find, don't you want to move over? Right, let's find the equation of a line parallel to, I'm going to give you a fraction this time, parallel to y equals 1/2 x minus 7 that passes through 811. Right? Passes through 811. If you want to draw it, but you don't need to draw it. So you've got your slope and you've got your point. You're putting it into y minus y1. So just to make sure everybody's doing the right thing, Harper, what's our slope? Our slope is 1/2. Why don't you want to draw? You're supposed to be drawing in yellow right now. Right, our slope is 1/2. And we're using this point, 811. And we're doing y minus y1, m, x minus x1. Alright, so try to get the equation. Again, I think there's a fraction with the half, but I think I gave you a nice number that it shouldn't create an issue. Well, no, it's 811. So 811 is right here. Right? So what you want to do is you want to say, okay, I have this point. What's my slope? So now we're going to go y minus y1 is m times x minus x1. Then plug in, plug in, plug in. Based on these two things. So what's the y1? Yeah. What's the m? Yeah. X minus. Yeah. No, maybe it doesn't call that out. Kaylin, what are we plugging into the M? 1/2, right? 1/2. Jake, what are we plugging into y1?
8.
Not 8,
Oh,
11. Adriana, how about x1? 8. All right, so it's everything in the yellow circle. So this one's not bad because I gave you a fraction, but when you distribute, it's still nice, right? You get 1/2 x, what, -4, right? -4. And then what do I do to get the y by itself? Just add 11, and what do we get? 7, right? We get 7. So this line and this line have the same slope, different y-intercept. So that's the easier one. Perpendicular one can be a little harder. Okay, so is everybody okay with the parallel one? Yeah? You just add it to both sides. So add 11, add 11. Oh, forget to do this. Since it's what? Yeah. Oh, so that's if you have nice points, yeah. But as soon as I start giving you weird points, it's going to be harder with fractions, right? So Manny's trying to do it like visually, right? And what I think he's trying to do is he's trying to start at 8/11ths and then kind of do you rise over your run, you rise over your run, you rise over one, see where you intercept. That's a more upgraded way. Right? All right, let's do our perpendicular one then. I need one more graph, perpendicular one. So again, I kind of did it out of order. So I'll use this one. All right, let's do a perpendicular one. All right, so we got an equation, right? We have y equals 3/4 x plus 3. And I want to get the equation of line perpendicular to. All right, so I want to make sure you guys understand what I'm doing here, right? Perpendicular, little upside down T. That means perpendicular. All right, perpendicular to the equation, y equals 3/4 x plus 3. That passes through 5, 1. I'm going to tell you, this one's going to have fractions. So you're going to want to write this one down, right? Because this one is going to know how to deal with fractions. All right, so I could draw it if I want, but you don't have to. Y-intercept 3, rise 3, and run 4. So, whoops, here's my line. All right, so I need to plot 5, 1. 5, 1's right here. I need it to be perpendicular. So it needs to form a right angle. So I don't know, I don't think you can really tell where it's going to cross the y-axis. So we're going to do an equation, and again, it's going to have, it's going to have fractions in it. So y minus y1 and x minus x1. So my suggestion to you first, put in the point, right? The point's nice and easy. Y minus 1 equals m times x minus 5. So I need to be perpendicular. Perpendicular. So, Cliff, which one's the slope? 3/4 or 3? 3/4. So my slope of this line is 3/4. So I need the perpendicular slope. I said opposite reciprocal. So if one is positive, all right, that one's positive, the other one's got to be negative, and I gotta flip it. So 4 thirds, negative 4 thirds. So that means in M, I'm plugging in negative 4 thirds. So the other class today definitely wanted to work with fractions a little bit. So how do we simplify that? Easiest way to simplify it. Marcus, what's this called when I do this? Apply distributive property, right? So negative 4 thirds x, negative times a negative is a positive. How do I multiply fractions? How do I multiply negative 4 thirds times negative 5? Negative times negative is a positive. How do I do 4 thirds times 5? Just go across, right? Marcus is saying go across. So 5 times 5 is 20. 3 times 1 is 3. Numerator, numerator, denominator, denominator. Here's the part that people don't like though. Right? To bring this 1 over, I have to add 1. Now adding 1 isn't that bad. How can I get rid of that 3? Good. Clear out your fraction. Multiply everything by 3. So you get 3y minus 3 equals 3 cancels, negative 4x, 3's cancel, plus 20. So then I can add 3 to both sides and divide by 3. So you get y equals mx, 3 plus 23 thirds. Easiest way with fractions, guys, is to multiply it and then divide it. Multiply it and then divide it. Oops, I forgot my x. So that's the hardest one, right? Hardest one. Let's try one more before we leave it. Right, so try this one. Let's do perpendicular to, what was that one? 3 plus? So perpendicular to negative 3x plus 7, passing through the point 8, 0. Perpendicular to negative 3x plus 7, and passing through the point 8, 0. So even though it's going to have a fraction, and I gave you a nice y part, I gave you a 0. So let's make sure everybody's using the right slope, right? The correct slope. So in order for you to flip, right, I would do this in order for you to flip. What's your question, son? Yeah. Yeah. All right, so Marcus, what are you writing down over there for the perpendicular slope? Positive 1/3. This one's negative, so this one has to be positive. And then I flip it over. 1/3. So that's my slope. That's my point. Plug it in and see what you get. And I'm recording this just so I'm going to write this one on the smart board too. Just get you guys set up. Right, so what do we have? Perpendicular to y equals negative 3x plus 7 and passes through 8, 0. So y minus y1 and x minus x1. This perpendicular slope is positive 1. So I don't think you have to multiply by 3 on this one. What are you getting, Hopper? 1/3 x minus 8/3. Good, right? Because this guy is 0. So this side cancels, and you get 1/3 x minus 8/3. Parallel and perpendicular can be the hardest. Right? 1/3 x minus 8/3. Okay? Vertical, horizontal should be incredibly easy. Parallel, perpendicular, little harder. So with those problems that we set up today, we're going to do something with parallel and perpendicular on this tomorrow, and we got started on it. Okay? This one is your homework. Okay? So I think 8 out of 12 of these, you should be able to finish in like 2 minutes. Why is number 6 different? Why is number 6 different? 5x plus 4y is 0. Why is number 6 different? Marcus just said it has a slope. How can you tell it has a slope? It has both x and y. So number 6, what you want to do first is you want to solve for y. Right? So number 6 is the same as negative 5/4 x. So number 1, number 2, number 3, number 4, number 5, number 8, 10, 11, 12, nope, 11. Those are all just drawing whether they're horizontal or vertical. The other 4, 6, 7, 9, and 12, you've got to put it in this form, right? You got to put it in y equals mx plus b. A lot of you guys did not submit homework today, right? So in order for you to have a partner, you got to remember, you need to submit all homework before you're coming into class. Okay? And again, gentlemen, are we picking Thursday? Marcus, Fanny, Cliff, are you guys picking Thursday? Yes?